Hi, this is Ms. Pellegrin, and today we're looking at Module 3, Lesson 5, using the identity and inverse to write equivalent expressions. So we are still looking at equivalent expressions. So today we want to recognize those properties of 0 and 1, and then the inverses, so our opposites and our reciprocals, in order to write equivalent expressions. Okay, so in your opening exercise, you are going to take a few minutes and read through and work each problem. Okay, so in the morning, Harris checked the temperature outside to find it was -12. Later in the afternoon, the temperature rose 12. Write an expression representing the temperature change. Okay, so it was -12. It rose, so it went up 12. Write an expression, and then it says, what was the afternoon temperature? The afternoon temperature. Okay, so not an equal sign. We are writing an expression, so we don't have an equal sign. So the temperature was 0 degrees Fahrenheit. Okay, part B, rewrite subtraction as adding the inverse for the following problems and find the sum. So remember, every time we see subtraction, we want to rewrite it as addition. So 2 plus instead of subtraction, and then -2. Okay, so we're still doing 2 take away 2. 2 take away 2. It's the same thing. And so 2 take away 2 is 0, -4, change, so we change in this, changing that, so we don't write plus 4, so -4 and +4 is 0. And they are additive inverses. Find the difference of 5 and 5, so find the difference of 5 and 5 is how we would write that, and so therefore we would have rewrite it as addition. Okay, different signs, they're additive inverses. 0. G minus G, rewrite it. So every time we rewrite this, we're writing an equivalent expression. So G minus plus a negative G is 0. No matter what that number is, the opposite of it together equals 0. What pattern do you notice? It's they're additive inverses, and they are equal to 0. Sum. And some of them are additive inverses. Okay, part D asked you to add or subtract. So here we've got addition, we're not rewriting it, it's just 16. Right here we have subtraction, so we will rewrite it 0 plus a -7, which is a -7. -4 plus 0, -4. 0 plus D is D. So what patterns do you notice here? We have 0 every single time, and every time we have that 0, it is equal to the value of that quantity. So 0 plus a number is equal to that number. Okay. So when we're looking at problem 1, what are the pair of numbers called? When we looked at that, we said they're opposites or they're additive inverses. What is the sum of the number and its opposite? It's always equal to 0. So add opposites and additive inverses always equal 0. And then in problem 5, what was so special about 0? And 0 is the only number when added with another number that will result in that other number. Okay, that's what we wrote there. This property makes 0 special among the numbers. Mathematicians have a special name for 0 called the additive identity. They call the property additive identity property of 0. So anytime you add something with 0, it's that number. And they just have a special name for that. Okay. Okay, so we're going to skip this. This is just showing that if you're adding 2 plus some number plus some number plus some number and so on, and your answer is still 2, the only number that it could possibly be is 0. Okay, so in example 1, we want to write the sum and then write an equivalent expression by collecting the like terms and removing the parentheses. Okay, so we're writing the sum. So we're going to write it out first. 2x and negative 2x plus 3. Okay, I don't see any subtraction, so I'm just going to regroup this. So we know that regrouping is the what property? And you should have said associative. So we regrouped it to where we have the x's together. That's what we're combining. Okay, so positive 2x plus a negative 2x. Okay, so the positive 2 and the negative 2 is equal to 0 plus 3. Okay. So these were additive inverse. Then this 0 plus 3 is that 0 property. And so our answer is 3. So we have 2x minus 7, and then the opposite of 2. So we're doing the sum and the opposite of 2x. I see subtraction, so the first thing that I want to do is I want to change it to addition so that I can move things around. So 2x, instead of a minus, we're changing it to a plus, and we have to make 2 changes. So negative 7 plus negative 2x. So I'm going to put my x's together. So I have 2x plus a negative 2x. So this step was our subtraction rule. This step is the commutative property because we're moving stuff to get it next to each other. And then we have plus a negative 7. And now we're going to regroup it, which is our associative property. And together that is equals 0 plus a negative 7. And so then we have our 0 property, which tells us our answer is a negative 7. Okay, so the opposite of 5x minus 1. So it's the opposite of this whole thing. We're taking away the whole thing. We're doing the opposite of everything that's there. So we learned that in our last lesson. The opposite of it. Of something in a group, we can just put that negative sign on the outside. It's the same as multiplying by a negative 1. Okay, and that meant the same thing. Negative 1 times 5x minus 1 is the same thing as that. Okay, so and 5x. Okay, so the first thing that I need to do here is I need to distribute. So a negative times a positive is a negative 5x, and a negative times a minus 1 is a plus 1. Okay, so the opposite of positive 5 is negative 5. The opposite of take away 1 is plus 1. And we just didn't write that extra step of showing that this was a plus a negative 1, which would be a negative times a negative, and you would have seen that that's a positive. We did not take that kind of extra step there. Okay. And then we have plus 5x. Okay, so that was the distributive property that we did. Now what do we need to do? We need to move the 5x next to it. So that gives me plus 1. So then I'm going to regroup that. So we did the commutative property. Then we regrouped. So this is the associative. That gives me 0 plus 1 is 1. Okay, so exercise 1 says with a partner, you're going to take turns alternating roles as writer and speaker. The speaker verbalizes how to rewrite the sum and properties that justify each step as the writer writes what is being spoken without any input. At the end of the problem, discuss in pairs the resulting equivalent expressions. So write the sum and then write the equivalent expression by collecting like terms and removing parentheses whenever possible. Okay, so this is just like what we just did in our examples. So one person will start out as the writer on A, and then one person will start out as the writer on B, and then the other person is just going to talk them through what to do, and you're just going to go back and forth with that throughout the exercise. Okay, I did not put the rest of those there. Okay, so do A, B, and I didn't seem to put the rest of them, so also do E. E is the, you don't have to write this, you have it, so I'm going to pause. Okay, so you had negative 4 and 4b plus 4. You move the negative, you have the negative 4, nothing was a subtraction, so you could leave it. You put the 4 next to it and then had 4b. This gave you 0 plus 4b, which leaves you with 4b. And the next one, 3x plus 1 minus 3x. So you changed it and wrote an equivalent expression to change it to addition. And then that's a negative 3x. So then you had 3x plus, and you moved that negative 3x next to it, plus 1, which gave you 0 plus 1. So your answer there was 1. And then you skipped to E. So the opposite of negative 7 minus 4b and negative 4v. So we distributed. Negative times a negative is a positive. Negative times a take away 4 is a add 4. The opposite of negative 7 is positive 7. The opposite of take away 4 is plus 4. Plus a negative 4v. This is what we want to put together. So we have 7 plus 0, which is 7. Okay. Example 2. We're multiplying. So go ahead and pause the video and multiply and get your answers. Okay, so you should have gotten 3 times 4 is 12. 4 times 3 is 12. So 12 over 12 is equal to 1. Okay, so here 4 times 1 is 4. 1 times 4 is 4 equals to 1. 1 times 9 is 9. And 9 times 1 is 9 equals 1. Negative times a negative is a positive. So 1 times 3 is 3. 3 times 1 is 3 equals 1. Negative times a negative is a positive. 6 times 5 is 30. And 5 times 6 is 30. So it is equal to 1. Okay. So what do we call these numbers? We call them reciprocals. What is another term for a reciprocal? It's the multiplicative inverse. What happens to the sign of the expression when converting it to its multiplicative inverse? So in other words, they're talking about this. Okay, so the multiplicative inverse, we keep the sign. The negative sign remains. What do we conclude? That it's always the multiplicative inverse, or the reciprocal, is always equal to 1. Earlier we saw that 0 is a special number because it is the only number that when added to another number results in the number again. Can you explain why the number 1 is also special? Okay, so 1 is that only number that when multiplied with another number, it results in that number again. This property makes 1 special among all the numbers. Mathematicians have a special name for it as well. The multiplicative identity. So additive identity was 0. Multiplicative identity of 1 is for 1 being a special number. Okay. Write the product and then write the expression in standard form by removing the parentheses and combining like terms. So the multiplicative inverse of 1/5. The multiplicative inverse is 5 and so it said write the product. So and now is going to mean to multiply instead of to add. 2x minus 1/5. And you're welcome to write the dot there. This is just how we will always see it. Okay. So we're going to do the distributive property. So 5 times 2x. So I'm just going to write it out while we're working. 5 times 2x is what we just did here. And then we have minus, and then 5 times 1/5. So 5 times 1/5. So 5 times 2x is 10x. Minus 5 times 1/5 is 1. So 10x minus 1, those are not like terms. We cannot combine them. That is our answer. Multiplicative inverse of 2 and 2, multiplicative inverse, sorry. I knew I was missing something there. So the multiplicative inverse of 2 is, we flip it, 1 over 2. And 2x plus 4. So 1/2 times 2x, that's what the arrow means we're doing, plus 1/2 times 4, again, what the arrow means we're doing. So 1/2 times 2, they are your reciprocals, so they equal to 1, plus 1/2 times 4, so 1 times 4, just write it out so you can see it, is 4. This is over 1, so 2 times 1 is 2. So we have x plus 4 divided by 2 is 2. The multiplicative inverse of 1 over 3x plus 5, so the opposite, so 3x plus 5 over 1. We don't have to put it over 1. And 1/3. We might want to put it over 1/3. Or not over 1/3, over 1. And just so it's easier to see. Sorry, this was in parentheses, which makes that look weird. I'm just going to erase these parentheses right here. Okay, so now it's still the distributive property. So 1 times 3x. So we're doing 1/3 times 3x plus 1/3 times 5, and I'm just putting it over 1 to keep it organized. So we know that this is equal to just x plus 5 times 1 is 5, 3 times 1 is 3, so x plus 5/3. Okay, so in exercise number 2, you're going to work in pairs, being the speaker and the writer, again, in order to do what we just did in the example right above. So go ahead, pause the video and try that. Okay, so the reciprocal of 3 is 1/3. And then you're multiplying times negative 6y minus 3x. Okay, so I see subtraction. I'm going to change that to addition. So negative 6y plus a negative 3x. 1/3 times negative 6y plus 1/3 times a negative 3x. So 1 times positive times a negative is a negative. 1 times 6y is 6y. 3 times 1 is 3. Plus 1 times a negative 3, x is a negative 3x. 3 times 1 is 3. We already should, that's why I'm showing that. So negative 6, negative divided by a positive, there's one negative sign here, so this is negative 2y, plus there's one negative sign here, so this is a negative x. And we cannot combine those. There's y, there's x. They're not the same thing. Oh, wait, but I do see 2 signs, so I should rewrite this. Negative 2y minus x. Okay, the multiplicative inverse of 4 is 1/4 times 4h minus 20. Change your subtraction to addition, to the opposite. So 1/4 times 4h plus 1/4 times a negative 20. 1/4 times 4h. Nothing's positive or negative, or nothing's negative, so it is going to be just positive h, plus positive times a negative is a negative. There's one negative sign, so it is a negative 20/4. So we have h plus negative 20/4 is a negative 5. We have two signs, so this is just h minus 5. Finally, the multiplicative inverse of negative 1/6. So the multiplicative inverse of negative 1/6 is negative 6 times 2 minus 1/6j. Negative 6 times subtraction, change it to addition. Do the opposite. 1/6j. Negative 6 times 2, so negative 12. I'm just not writing it out this time for sake of space. Plus negative 6 times a negative 1/6, so a negative times a negative, we have two negative signs. Therefore, what I'm multiplying is what I have two negative signs with. So therefore, that's going to be positive. And 6 times a 6th is 1, so that's just j. Negative 12 plus j is my final answer. In conclusion, what are the other terms for opposites and reciprocals? And what are the general rules of their sums and products? So, additive inverses and multiplicative inverses are the same as opposites and the same as reciprocals. The sum of the additive inverses is equal to 0, so opposites are equal to 0. The product of multiplicative inverses is equal to 1, so when we multiply reciprocals, we get 1. What are the additive property of 0 and multiplicative identity property of one state? The additive property states that 0 is the only number that when added to the other number will result in that number again. Multiplicative states that one number of 1 states that 1 is the only number that when multiplied with another number will result in that number again. Okay, so that is the end of our lesson. That was our objective, was to be able to see those two properties, recognize the identity properties of 0 and 1, so opposites, reciprocals.